Good afternoon, folks. Welcome to the Carbide Office Hours, episode 7, I think, live stream. The weeks are just blurring together at this point. Hope you're all doing well. Hope you're all staying safe and busy. Today, I just wanted to go over a couple simple examples from Carbide Create Pro, just to go a little more in-depth about some of the features, because I know I've kind of glossed over some of them. Let's see, who do we have here? We've got New York representing, New Zealand, all over the place. Thanks for joining in, guys. So, without further ado, let me just jump into some stuff in Carbide Create Pro and explain some of the features and how the components interact, and you guys can just drop in some questions as we go along. So, let me first just start by drawing a couple components and showing you the options for combining them in Pro. So for those that haven't used it yet or haven't dug through the options too often, in Carbide Create Pro you can pick a profile and you can apply just sort of different ways of extruding these features out. So you're basically just selecting a contour and just pushing it up or down and adding or subtracting them, but there are some other options that you can play with. So if you hit the drop down in the component parameters, this describes how different bits of geometry or your model interact with each other. Usually we're just doing addition, subtraction, but there's a couple others that are really useful, namely min, max, and equal. So if you imagine something like this could be a cross-section of what you're trying to make. As you extrude out shapes and you want to combine them, if you do a add function, it's going to take the height of one object and add it directly to the other. So if you pretend that my mouse moving up and down is the just vertical cross-section, once it gets to the intersection of two shapes, it's going to add them together. So here you're going to have basically double the height of, I wonder if I can draw this out. Hold on. Paintbrush tool. This is going to be, so if I'm drawing out the shape of what this profile is going to look like, it's going to look like this. It's going to come over, it's going to start going down, and then here we have the constructive interference of two parts. So you're going to get something that looks like this, and then the continuation further down. And then, well, it'll actually go all the way down to here and do that. So this is the profile you would get. So that's what happens if you do addition. If you do subtraction, you get destructive interference. And then the more interesting thing you can do is you can do max or min. So if you imagine just a line going straight down of, let's see, why is my pixel width? Oh, I'm still on eraser. So if you imagine a line going straight down of the computer trying to figure out what your geometry height should be, if it's max, it'll stop at the first piece of model it hits. If you're going for min, it'll go for the lowest point, so here. So keep that in mind as we go through this next example. And then also, if you use the equal function for your component blending mode, that's just going to mean whatever the last thing you created was. If it's maybe if you drew this, it'll just be whatever you just modeled. You decree that this top height is what the 3D model is going to be. Lots of echo. Let's see. I'll see if I can just maybe not talk super loud, but still keep my voice in a reasonable range. Text on Z-curve, concave, convex. So we're going to touch on that a little bit, I think. So for today, what I want to do is just make a simple sign with a border and with a texture in the middle. So what that's going to look like is, I need to delete this component. The components, once you generate them, are independent of the contours. So they shouldn't, you'll have to delete them separately or just start a new canvas. So right now I have my setup as a foot across, 4 inches high, and a stock thickness of 0.75 inches. So I'm going to start by making a rectangle. I hope that's the middle. And then let's put a little fillet on here just to make it classy. Radius of maybe 0.3. And then let's make another rectangle. So this will be the inner and outer borders of our make-believe sign. Let's do another fillet there, maybe 0.15 inch radius. Good enough. It really doesn't matter here for this example. And then let's throw in some text. So let's see, what's a good good font? Maybe, let's see, obviously. And then something for your average home machinist. How about 0.75 font height? Perfect. Let me just center this real nicely. So X value of 6, Y value of 2, that puts us dead in the middle of the canvas. And then this will be the font for our sign. Now for the texture portion of this sign, I'm going to make a fake sort of water texture. If you don't know or don't have a way to create your own, an easy way to do it is to just search online for height maps or bump maps or texture maps. You see this a lot in the video game modeling world, so if you ever do any Unity or Blender work, you'll see these. Thanks for reminding me about COVID, Google. Let's try water texture height map. So you could totally get a black and white texture map from one of these things, but I'm gonna do a really quick and easy way to sort of make cheap clouds or water in my image editing software, which is Affinity Photo. You could totally do this in Photoshop as well. Photoshop, there is a filter and you can generate sort of quote-unquote clouds. It's not really clouds, it looks close enough. But in Affinity Photo, that feature is called Perlin noise. So if I make a new layer, if I choose my two colors as black and white that I want to generate it for, and I make sure I have a layer, I go to Filters, Noise, Perlin noise, and then you can change some of the features, the scaling, to create a texture you want. So this sign is going to be somewhat low resolution and it's kind of small, so I don't want anything too huge. I don't want waves that are super fine. This should give me a reasonable rolling texture. I can change some of these parameters. Some of them are more subtle than others. Persistence, whatever, good enough. So I'll apply that and I will export this as a JPEG. Let's go 80% quality so the file is not humongous. Desktop, and I will call this cheap water. Okay, so now that we have a texture that we can bring in, on command, I will first start creating the body of my sign. So I'll pick the outermost profile and I will extrude it upwards to a total height of about 3/4 of an inch. So the way I'm going to do that is I'm going to select, I also want to put a chamfer or a bevel on the edge just to make this nice looking, quote unquote. So 45-degree chamfer, limit the height of that chamfer to, let's say, 0.15 inches. We'll call this the main extrude just to keep track of it, and we'll add a base height of 0.6. So these two together should give us a total model height of 3/4 of an inch. Let's see what this looks like. We have a bevel on the side, and yeah, nice thick block. So for the remainder of this sign, I want to create a pocketed area where I can add my texture and also extrude out my text. So I'll pick the inner contour, and I will apply another component to it. This one, let's also make it chamfered. Let's make the max depth of this depression 0.3 inches. And then let's make sure this is a subtraction. Let's call this the Great Depression. Apply it. Let's see what this looks like. Oh, that is way too much. Oh, it's because I forgot to set a height limit. So this is just going to do a 45-degree slope all the way down until it hits the center of the Earth. So we will limit the height, and then it'll respect the 0.3 inch max height constraint. And so now we've got a little pocket in our sign. So let's see. Let's hide this. Let us bring in our fake water texture. So I'm going to select this contour because that's where I want the texture to be. And then I will use the texture feature and navigate to the JPEG that I created, cheapwater.jpg. Give it a second, it's going to crunch it. And so right now, what's going on is it is tiling this water. You can sort of see some of the lines of how it repeats because it brought it in by default at a 45-degree angle. I really don't care for how that repeats. I want, since my texture is sort of in a 16:9 landscape format, I'm going to set that angle back to 0, and let's see where we land. Give it a couple seconds to calculate. This looks okay. I think there's probably a seam line somewhere where this repeats, but this actually looks pretty okay. So we'll keep this here. And now you can see that around the borders, the texture is sort of coming up over beyond the lip of our sign. And that's because we're doing an addition operation. Now, if you remember our little fake example of the different modes you can blend these models in, we actually want to use maximum. So either the surface of the water or the body of the sign, whichever is higher, that's what you want to keep. So I'll do a max, and then I will also add a base height, because if you don't add base height, you're going to have something that looks like this. The texture is actually going to be below here. You won't see it because this bottom pocket will be higher than the water's surface, so we need to add a little bit of height here. Let's go 0.525. Let's see what that looks like. And so that brings up the surface of the water to a region where it can be taller than the bottom of the original pocket. The red is showing me that some areas are clipping through the maximum stock thickness I have set. So maybe if I lower this to just plain old 0.5, that should fix that. All right, so that's basically how you apply texture. If you were using a smaller texture that was maybe repeating several times, you could change the scaling so that it would fill whatever area you had without repeating. Or if you could find it, you could search for texture maps that repeated. Some of them have seamless borders where like one side will match up with the other. You can usually find this with like brick textures or gravel textures in game design. Let's see. How do you get Carbide Create Pro? So right now, if you go to, I think we're still running it, launch.carbide3d.com/promo, and you create an account, and you can request a 1-year license. And then once you have that license, you can go into the help, and there's a little drop down where you can register the license that we give you, and that will unlock the pro features for 1 year. All right. Let's see if there are any outstanding questions. Just remind me when we get to the end. We'll do a little Q&A. So with this texture in place, I will remember to name this water-ish texture. Apply that, call it done, and then let's deal with the text. So we want this text to stand out from the surface. So let's add a component. Let's make it 0.75 inches tall. And we're going to do sort of just an absolute, hey, this text is going to be at 0.75 inches high, no ifs, ands, or buts, and use the equal function to force that constraint. So now we have the text extruded outward, and that can be a really basic sign. So this could have been a technique you would use for the community challenge we just had that just concluded. And there's a lot you can do with it, especially with the textures, choosing how you apply it. If maybe you want to create a border around the text where maybe, because right now if you try and machine this, around these corners, if you use a ball end mill, there's going to be a little fillet around your text. So what you could do potentially is leave a little relief area outside the text that doesn't get textured. So just little things like that. Let's see. The link was launch.carbide3d.com/promo. I will put it. Carbide Answers has you covered. Just make sure that when you apply for the license, the URL ends in /promo at the end. To machine this sign, you would go into the toolpathing window and you would work based on the contours that you have drawn. So based on what I have, this model, I would actually honestly probably run the outside on a router table just because it's a little faster. Just put a little chamfer bit in there, flip it over, and then use a chamfer bit with a bearing so you can run it along the outside. But for the inside, that's where you would really need the CNC to machine the area. So I'll pick the inside contour. I'll do a 3D rough using a, let's say, 1/4 inch end mill, maybe 201, or the 251 down cutting. The parameters are basically the same. And let's see, step down, depth per pass. I like to go a little shallower but faster for roughing out features like this, because otherwise sometimes if you have thin features like the apostrophe, those can actually get knocked off if you take too aggressive a cut, and you can reduce cutting forces on your material by reducing depth of cut. So let's see what this looks like. It'll take a second to calculate. Not expecting too much. All right, so let's show the simulation. It's clearing a little bit, but for the most part, because the text came right up to the top of the stock, there's not a lot to machine away. So for the remainder of the text, I would do a 3D finish with preferably as small a ball end mill as you are comfortable with, although the smaller it is, the longer it'll take. But for this example, let's just say the 1/8 inch ball end mill. Select that, pick a step over. I like, for a rough model, about 10% cutter diameter. For something a little more detailed, maybe 7 to 5%. Let's do 7.5 thou. Let that calculate. It'll make a raster style toolpath. We could probably push this a little faster. We could also reduce the step over because the time estimate is not too friendly. But let's show the simulation, what that'll look like. Toolpath is a little too much. So this is a representation of what it'll cut out. So yeah, pick and choose your textures depending on what you want to do, and keep in mind that certain areas, the ball end mill isn't being properly rendered, it's being rendered as a flat end mill, but there will be a small fillet where you have sharp corners meeting up. So, let's see. The that is sort of like the basics, just the basic tools, how you add and blend components. And if you have any specific questions about that, you can throw them in now. I'm going to move on to a different example of just something I've been playing around with, which is this. I had the idea to, whoops, not that. Let me pull that up again. So I had an idea of doing a topographic carving with an epoxy sort of inlay around it, just matching the contours of where bodies of water might actually be. So this is the Hawaiian Islands with a little extra, and if you are able to find, let me see if I can pull this up again, Tangram's height mapper. So this is the site I use to get my topographic data, and right now, unless you have it selected, all the features that are water are just pure black, so they wouldn't wouldn't produce any sort of height data. But there's actually a checkbox you can do to include ocean data, and that adds a lot more detail to an island. And if you bring in a height map like this, you can have the islands themselves recessed, or not, proud off the floor, off the ocean floor, so you can actually pour an epoxy and get that contrast. So I'll show you guys how I did that, and I want you guys to let me know if you think I should make a video on this, because I did make a lot of mistakes, which I will point out later. I do want to do a longer island series, but for this first proof of concept, let me know if you think the mistakes are too catastrophic to show, or if I should just gloss over them in an actual video. I have broken Carbide Create, so let's just restart that. I don't care about the bug report. All right, let's try this again. So this is going to be in a roughly 4x4 inch canvas, and then we can always cut this down later. So I'm going to go into the setup, and then I'll make this a square canvas, and then I'll add in some borders. The reason will be explained shortly. So I'm going to do a radius of, I'm going to make this not 4x4. I want this, the cutout of this piece to be a little smaller than the actual topographic carving that I make. So we'll do 3.75, so we're trimming off 1/8 of an inch all around. Let's apply that, see what it looks like. Good enough. And then I'll go into the model workspace and I will bring in, so depending on how you export your data, you can get a couple different things. You can get just Hawaii only. You can get Hawaii with the islands, or they can also trace out where the islands are. None of these are really useful just because we're just going to machine everything in one shot. So I have isolated a crop of Hawaii and the surrounding ocean area, and I will bring that into Carbide Create using the import component feature. Let's see, where is this? This is on my desktop. This is in the Carbide Office Hours references. Hawaii with ocean square.jpg. Give it a second to crunch through everything. Let's show the 3D model. That is super duper aggressive. Let's make the height variation at most 0.3 inches. Let's see how that looks. Better. But we do, well, just for my own edification, I want to see a little bit of thickness in here, just so that this isn't completely flat, even though we're only going to machine down to the ocean surface anyway. Looks decent enough. And then we will just hit done. That's really all you need to machine this. Also, I just want to point out that if you invert this, you could actually use the import component feature to maybe make a lithophane. So you have a lot of options there. Let's see, any good questions? What is the best workflow for taking something colored, making it grayscale to bring it into Carbide Create Pro? If you have any image editor that you prefer, there's usually a way to desaturate the image and bring it in. The thing about trying to carve a black and white image is that unless you have specifically a height map, the darker areas and lighter areas don't necessarily correspond to what you want, maybe in front or in the background if you're doing a relief carving. Let's see, anything else? So if you could get like a 3D map of something, like if you had like a Microsoft Connect, or you could map a surface, you could totally scan in an object, bring it in. There are tools that you can use to take an STL or a mesh file and then turn it into a height map. But if you had that mesh file to begin with in a native STL format, you could also use something like Meshcam. You could turn it into an image and then do a workflow like through Carbide Create Pro, or you can just work natively with that mesh. All right, so we are not making a lithophane. And then, so let me undo the invert, apply that. Once you have your geometry, I need to draw one more rectangle as soon as this gets me out of the settings. And this will just be where I want to machine initially. So I will do not a contour. For the contour that has everything surrounding it, or is surrounding everything, I'll do a 3D rough. And then I will do a 3D finish. I'm not even looking at what tools I'm using, just this is an example. So same contour, 3D finish, 1/8 inch. Well, for here I used a 16th inch ball end mill with a much smaller step over. And those are the two toolpaths I needed to carve out the topographic map. And then afterwards, I came back and I cut around the innermost contour, because when you pour epoxy, which I will show the project montage later, you get a little bit of a meniscus around the edge, and so you can sand away some of it, and also your edges aren't going to be perfectly clean, so that just makes it a lot easier to clean everything up. And so I would just contour around the outside of this to the bottom of the stock, and that's basically everything you need to create the starting point for a topographic feature like this. The cutout toolpath is something I would do later. I would just do the roughing and the finishing, pour my epoxy, and then do the cutout. So let me show you guys that. Let's see, let me maximize this a bit, and then let me hide my face because no one wants to see that. All right, so I started with a 3/4 inch block of walnut. First operation, I actually did a really quick pocketing operation to face everything down, and then it switches from there into the 3D roughing toolpath, so you can see the raster style clearing operation. The deeper you go with this toolpath, the slower it'll be, because it works around the different islands and it comes back to machine what it missed. So you can see it's defining the islands more and more. But then as it gets to the ocean floor, there's a lot more little features and mini volcanoes underneath the ocean that it takes longer to machine everything out this way. But eventually, it'll clear everything out, and then we will switch to a parallel finishing toolpath with a 1/16 inch ball nose end mill. All right, I clearly made this montage far too long, but this just illustrates the point that those last couple step downs are going to take a little longer. This is sped up, I want to say 300 times. My step down's about 7/1000 of an inch. And I actually thought about coming back with a 1/32 inch ball nose end mill just around the Hawaii portion, and I can show you guys how to focus a machining operation there, just because that's the only geometry that's going to be visible outside of the epoxy. So there's really no point doing everything in a super high resolution. Here's the cutout operation, and at some point I realized that I didn't have any tabs or tape holding the outside of the material, so we had a little bit of a stock escape issue. So that is what it looks like after the machining operations. From here, you can sort of just maybe use some sandpaper, clean up the edges, just so that the epoxy doesn't fuse to uneven features. I'm coating everything with polyurethane just to seal the surface of the wood. Otherwise, the wood fibers can release a bit of air and you get bubbles. I'm using 2 different shades of blue mica pigment powder, and I'm using Total thick set epoxy. You could use any sort of casting resin that lets you pour deeper than a 1/4 inch. I'm not going quite that deep this time, but you just don't want your epoxy to overheat. So I'm mixing in pigment powder. This is really boring, and I'm pouring everything in slowly, working around. And because of the viscosity of the epoxy, it's kind of hard to get the definition in the islands. So this is definitely not what you would consider an accurate map, but it's pretty close. It's enough to give you an idea of what you're looking for. And the interesting thing about epoxy is, as it settles, as like that meniscus forms, or as things like height variations even out, you get convection currents in the epoxy. So if you want to do sort of artistic swirls, you want to wait like a couple minutes afterwards, as the epoxy settles out, and you can leave in whatever swirls you want. I tried to follow what the actual ocean currents around Hawaii were, and then once that's set for a couple hours, you come back, you pour in about 1/8 of an inch of just pure clear epoxy, and that way the surface is completely clean. You could use it as a coaster, or just any sort of paperweight. I do highly recommend making sure that whatever you pour this on, you put some tape, packing tape or whatever, on the bottom. Otherwise, you're going to stick everything to your wasteboard, which is a really bad day. But once you get everything pried off, there's that meniscus that I was telling you about that you need to sand flat, or you could machine it flat. But once I sanded it flat, I think I forgot to show a small cutout that I did additionally with that, where I sort of just rounded over the edges. Then I went over everything with a chamfer bit, which was a mistake, and I will point out why in a couple seconds. I used a popsicle stick to smear on some tabletop epoxy, so it's just a slightly thinner version. It's meant to go on thinner, it self-levels. You should probably use a high-quality brush, I will say, with this, because if you apply it too thick, it'll go over the edges, and it's going to start building up. So what I'm trying to do is scrape off just the little extra lip of epoxy that's been collecting on the edge. And if you apply a really thin coat, that's not a problem. But because I was trying to save my foam brushes because I didn't have a lot left, I just used a popsicle stick and sort of globbed on a lot, and it could have gone better. So don't do what I did. Use the heat gun to just pop any bubbles, increase or decrease the viscosity so it flows and flattens a little better. And here is a close-up of the model, and there's a couple small defects that I'll point out. Let me try and catch the light at the exact time. So there's a flake on the right side of it where I think I was mixing in a used container. So I had a little chip of old cured epoxy go in with everything, and I didn't notice it. There's a couple specks of dust in here because I was letting this cure in my CNC enclosure. Terrible idea. You should try and do this in a nice clean place if you can. And then also around the edges. Epoxy and hard corners don't always work well, especially for self-leveling compounds, because there's some surface tension there. So you can see that it doesn't overflow the corner super well. So if you can round this over, instead of using a hard chamfer, it would probably come out a lot better. And then also around the edges, I didn't show it, but I need to do a little better sanding because my adhesion wasn't super great. And then there were actually some air bubbles that I didn't notice when I was first pouring this because the lighting in my enclosure is super uniform. It's coming down from both sides. And here I just have a light off to one edge, so you get a lot of edge reflection off the bubbles. So I really didn't notice this when I was pouring, just because the environment I was working in was super uniformly lit and it doesn't show these imperfections. So that's another thing that I'll have to just keep an eye on, and I make sure I take out when I'm doing this another time and learning from my lessons. So let's see. This piece, I'm probably going to end up chopping off the bottom 1/4 inch, thinning it out a little bit, and then just putting some polyurethane on the bottom. And then this can turn into a coaster. I'll probably bring it to work and give it to one of my coworkers who seems to be subtly hinting that I should. And then I'll work on a different island. I'm not sure what to do next. I'm thinking Iceland, Japan, Taiwan, or the UK. But if you have any suggestions, let me know. And also let me know if you think that this project, mistakes included, should be a project video, or if I should just wait until I just perfect everything and then release a video. So that is basically just an experimental topographic thing I was playing around with this week. And yeah, it was fun, but there's a lot I need to improve on. Price for Carbide Create. I think there's going to be two prices. One is an annual subscription. One is a higher flat rate price. I think the price if you buy it standalone is going to be like 3 years worth or something. We're not finalized on that yet, but it should be under $500 all in, I think. Let's see. How difficult would it be to model a micro chamfer on lettering or anything other than flat lettering? Let me see if I still have this. Let me start a new file and let's see if we can model that up real quick. So, actually don't even need that. Let's just go straight to making text. Text is up here. Let's drag it down, and then let's call this chamfer. And then let's try and extrude this upward with an angled constraint around the border. Maximum height of 0.02, maybe, with height limit enabled and a base height of 0.1. Let's see what that looks like. So you can get a little micro beveling on your letters. I don't know if you mean around the outside of the letters. That's a little more challenging. But if you want a beveled or rounded look on your letters, this is a way to do it. So let's see. All right, let me go through the chat, see if there are any outstanding questions. Let's see. I'm not seeing anything outstanding. If there's anything good that I missed, Carbide Answers, can you just throw that in the chat? And if anyone else has any concluding questions just based on what I've shown, let me know and we'll try and get to it. I'm going to pull up that again just because that's more pleasing to look at. Has the limit switch and still does not stop sad face. So the homing switches are just on one side of the axis, and that's how you home. Limit switches in particular, we don't offer those, but those are a second set of switches that you put on the opposite end, and you would need to enable hard limits in Gerbil for those to actually do anything. You can also implement soft limits. Let me Gerbil configuration. So I know this is going to be a little technical, but it's just for the people who know what they're doing, this can be useful. Soft limits is parameter 20, so you would enable that. And if you want hard limits to be enabled, you need to change parameter 21. So those would be what you would change for the machine to just automatically stop when it hit one of the boundaries of the machine, or when, like, let's say you program a cut that's too big that doesn't fit on your machine, you can enable these. But we have them disabled by default because the jogging limits built into Carbide Motion will stop you, and a lot of people get weirded out when their machine just stops and no one, like, there's no, like, hey, like, you exceeded your bounds. Like, people tend to get confused when that happens. So we try and keep everything internal to Carbide Motion. let's see. Eventually, once I can work out the Wi-Fi in my garage, because the garage is on the opposite side of the house from the router, I'll try and do a live stream in there around the machine so I can actually answer machine questions more specifically. And then I might also do a sort of like a one-take video. We'll see. I'm going to apply import an arc into DXF format into CC. It loses definition. Arc is no longer smooth. So DXFs can be tricky because there's a lot of different formats and compatibility things. If you can convert it to an SVG first, that's usually better. And let's see, I don't think I have an example easily available, but I think you can potentially change the nodes. Let me try. If I go into node edit mode, I don't think I can change these, but in Inkscape or something, you can pick the nodes in your file and convert them from like vertexes to like curves. I'm going to try and pull this up in Designer just to give an example, but SVG is usually a better fit for what you see as what you get when you import it into Create. Let's see, where's my pen tool? So if you draw a vector, let me try and zoom in like this. There are different node styles that you can change. So some of them are hard corners, some of them are rounded corners, and it's usually just a matter of the software not exporting the correct information. But if you can bring it into a vector design software and you're not doing this directly in like Fusion or SolidWorks, you have a lot more control over making sure that your vectors come out properly. Future PCB video, I would like to, and I've actually got a project in mind, but I need to brush up on my circuit design, and I probably just harass one of my bosses to make something for me. So, anything else? Let's see. All right, well, I think that pretty much covers what I wanted to talk about today. I don't think I added a sufficient reminder in this, but one other thing about importing in features is that if you have pure black or a PNG that has transparency, those areas are not brought in by default. So let me just import in, let's see, desktop, references. So if I bring in this horse, the areas in black don't show up. So if you show 3D and you try and add a base height to it, the area around it won't be modeled. But if you include, if you hit the checkbox for include ambient area and you apply that, then you'll get just the whole rectangular area extruded upwards. So if you're doing topographic maps where the ocean or some other features are just fully saturated black, that's how to work around them. All right, so thank you all for tuning in. Hope this gives you some project ideas you can do in quarantine. And until next time, stay safe, keep making. Thanks for joining in, guys.